So our team member are going to present about our project. There will be the stackable spring flat rack. Our group member consists of me, myself, Esther Nakai Musa, Solomon J. Raj, Lechumi, Muhammad Haris bin Ismail, Muhammad Hafizuddin bin Muhammad Rozi. So for the introduction of this part of our presentation, I'll be explaining our project on stackable spring flat rack. So the aim of our project is to show the vibration in the chapter of this subject, that is mechanical machine. The part that shows the vibration the vibration mechanism will be the spring. The spring lifting plate mechanism is a mechanical system designed to lift and support heavy loads using the energy stored in the spring. The mechanism consists of several key components, including a lifting plate, springs, and support structure. The springs are strategically placed under the lifting plate and are responsible for storing potential energy when compressed. When the plates are removed, kinetic energy comes in, while the spring decompresses as it will move upwards. The objective of this project is to understand the build concept of a plate rack, to study the concept and type of force acting on the spring, and to solve the calculation method used to determine the force act on a spring. The problem statement are: what are concepts on building a plate rack? What are the type, force, and its concept acting on the spring? How to produce a calculation method to determine the force act on the spring in the rack. The scope for this project is used in household, restaurant, franchise, and many more.
Now, I would like to present about my part, which is literature review. So, stackable spring plates, rack parts, and tools. So, this slide shows about the parts of stackable spring plate rack. So, first picture shows about the spring, and then second one is nails, and third one is woods. This slide shows about the tools that use for project stackable spring plate rack. The first picture shows about the gloves. Second one is a face shield. Third one is grinder machine. And then this slide, fourth picture shows about the hammer. And then measuring tape. And last one is wood craver. Next slide is about the principal operation of stackable spring plate rack. A kitchen item called a stackable spring plate rack is made to store and arrange plates in a small, space-saving way. A stackable spring plate rack operates on the following principles. First one is construction, and then spring loaded design, plate placement, fourth is stackability, easy access, and final one is space saving. Overall, the stackable spring plate rack provides a practical and room saving option for kitchen plate storage. Because of its spring load construction, the plates are held firmly while still being convenient accessible. Application of mechanics machine in stackable spring plate. A spring is an object that stores energy when force from a load is applied and releases the energy when the load is removed. Regardless of the type of springs used in product. In a spring, while often change to its original shape if a load is removed. Any product that uses springs must adhere to Hooke's law. Hooke's law only explains how springs elasticity and the force applied to its interact. According to Hooke's law, the force required to compress and extend a spring inversely related to displacement. Mathematically, Hooke's law is expressed as F equals to negative kx. So F is force applied to the spring, and then x is displacement of the spring. The negative value indicate that the restoring force is opposite of the direction. And then the K is the spring constant. It depends on the type of springs and shows stiffness. And then this image shows about Hooke's law. Different types of helical springs. Helical springs, the most typical springs used in product manufacture are helical springs. Helical springs are created by coiling wire into helix from thus the name using various cross sections. The spring types listed below. First one is compression springs. Compression springs are open coil helical springs that withstand axial compression and have a fixed coil diameter and changeable from. It used in the ballpoint pen, which produces the popping sensation, is the most basic example. It is also appropriate for suspension and valves. And then the second image shows about the extension springs. Extension springs are closed coil helical springs as opposed to compression springs. They work well for building tension, holding the energy, and utilizing the energy to reshape the spring. Garage doors are a straightforward illusion of its usage. Other can be found in weighting scale, jaw pilers, and pull levers. And third image shows about the torsion spring. The two ends of a torsion spring are used to fasten it to distinct parts. This maintains a particular angle of separation between the two halves. When a force is exerted radially because of rotation, these springs employ the radial direction. Furthermore, customized two-bodied torsion springs may be made in large quantities using CNC machining capabilities. That's all from me. So now I pass my slide to the next presenter. Thank you.
Next is methodology, where in this chapter it emphasizes a crucial methodology that must be carefully chosen in order to address the difficulties present. Additionally, it provides a mean of organizing and gathering the exam data. In-depth description of the approach used to start this project are covered in full in of this chapter. The project was completely perfected because the right method were employed, which were in accordance with the project goals. Next will be the flowchart, where first we have done our brainstorming and get idea with the knife sharpener, which was proposed and was not approved by the lecturer due to the cost and the material needed. And we have done again with our brainstorming and get with the stackable spring rack, and it was been approved on the proposal. And we continued with the buying material and usage of tool, where we get some material from trash and we have done reusing, and the tools we have get from the lab of the mechanical of the university UTHM, and we have done the project was continued with the assembly and fabrication. And after doing the fabrication and assembly, we have done with our project testing and found out some lackness in our project and has corrected with the extra tools from the lab and continued with our project testing, and our project was successfully done. And after done with the project testing, we continued with our calculation using the concept of vibration of mechanical or machine. And finally, we have done our report writing and has present our project to the lecturer. Going on with the Gantt chart, as we can see here, these are the task activities and the weeks that has been done. As we see, title selection was done on week 4 to 6, proposal was done on week 6 to 7, tools and item purchase was done on 8 to 9, product assembly and fabrication was done on week 10 to 12, product improvement was done on week 13, product testing was done on week 12 and 13. Report writing has started from the week 8 to 13, and our final presentation was done on week 14. Next will be the data collection, where we review from group members. We get all the ideas of our group members by doing brainstorming and meetings. Next will be the internet, where we get to understand and do study and research about the mechanical hardware, material needed, the way a process of a rack works, assembly process of a rack, and many more. Next will be our advice service, where we get advice from our lecturers and team members to more clearly understand about our project and the problem that we are going to face towards the project product. Going on to part selection, we are going to see the tools that we are used in the project. The first one will be the wood saw, where we used to cut a small measurement of wood from the pallet. Next will be the screwdriver, where we used to turn the screw in the project. And next will be the electrical hand drill machine, where we used to make hole on the board that will be placed the spring into the hole that was provided using the electrical hand drill machine. Next will be the electrical handsaw, where we used to cut a big pallet into a small pieces of wood. Going on with the metal file, we use it to smoothen the surface of the cut wood, and we use hammer to nail the project together. Next will be the equipment and the raw material. The first one will be the spring. The spring is connected to the board that holds the plate and to the top layer of the project, and it is used in the calculation process. Going on with the raw material, that is the pallet. These pallets are used as the wood material for the frame and the body of the project. Next raw material is the board, which is used to hold the plate and act as a base. Going on with nail and screw, these are used to attach all the frame and the board together with the spring. And finally will be the bracket. This bracket is used to attach the frame together and to attach two boards together too. Next is the preparation of material and estimate costs. As we can see here, most of the items are free except for the nail and screw, wood board, spring, and the L bracket, which we had to buy. And as you can see here, there are few quantities. Most of them are just one quantity, except for the wood board is 2, spring is 4 springs, and L bracket we used about 8 L brackets. Next will be the assembly and fabrication process, which is the process of doing the project. And first we have took a pallet and cut down into a small pieces wood, where our project height is 55 cm, width is 45 cm, and length is 40 cm. And the wood quantity needed to make a base is 4 wood. The truss that hold the project is 4 wood, and the top part will be the 5 woods. After cutting down the pallet into small pieces, the base part of 4 wood was attached together using nail, and a L bracket of quantity of 4 was attached on the top of the base, where the L bracket act as to attach the truss together with the base. And on the top part of the truss, we use screw and nail to make a top layer using the 5 wood that we have provided just now. Next, make some hole on the board that are going to be the plate holder using electrical hand drill, and use the measurement that was provided. After that, place the spring on the hole was provided using the electrical drill. After finish placing on the spring on the board, make a drill on the top layers and place the spring that has been placed on the board together on the top layer. After finishing the attachment of the spring on the top layer, place 4 brackets between a board of the base layer and the plate holder and attach them together. And finally, your project is done, where we can press the base layer to place the plate inside our project. Next is the design process, where we use the SolidWorks software to get a precise measurement of the project. And here are the following pictures, where at the top layer we can see the complete project product with spring, and the bottom will be the complete project product with spring and with the dimension of the project. The final methodology, we get to see the product testing, where after assembly and fabrication done, with some improvement done between the process, we get to see that the spring has stand a lot of force that is given from the plate that we have attached in different type of situation, where we have given a lot of plate to the rack or some plate on the rack, and the spring has given a great strength to hold all the plates that we have provided in the test. And finally, after the test run, recommendation from our lecturers and some improvement done, we get to know that our goal has been achieved in this process.
Hai, Assalamualaikum warahmatullahi wabarakatuh. I am Hafizuddin. I will present about result and calculation for the report of mechanic of machine. The plate dimension is 25.4 centimeter. The plate weight is weight for 1 kilogram. The rack capacity is maximum weight of 20 kilogram, and the spring rate is 0.907 kilogram per centimeter. For step 1, calculate the maximum number of plates based on the weight capacity. Maximum weight capacity is 20 kilo. The plate weight is 1 kilogram. Maximum number of plates is equal to maximum weight capacity divided by plate weight. The maximum weight is 20 kilo divided by 1, and the total number of plate is 20. Step 2 is calculate the spring compression required for each plate. Plate weight is 1 kilogram. Spring rate is 0.907 kilogram. Spring compression per plate is equal to plate weight divided by spring rate, and the spring rate per plate is equal to 1 divided by 0.907 is equal to 1.103 centimeter. Step 3, calculate the total height of the rack. Rack required for the maximum number of plates. The plate diameter is 25.4 centimeter, and the total height of plate is maximum number times to the plate diameter, and the maximum number of plate is 20 times to the 25.4 centimeter is equal to 508 centimeter. Step 4 is calculate the spring constant. Maximum total number of plate is 20. Force of plate is 20 times 1 times 10 is equal to 200 Newton. The extension spring for X is 10 centimeter. By using the formula F equal to Kx, F is 200 Newton equal to K, where we could define using this formula, and X is 10 centimeter, and then K is equal to 20 Newton per centimeter. Thank you. Now I will continue with the comparison between the stackable spring plate rack and regular plate rack. The first one, for the space efficiency, the stackable spring plate rack is multiple plates can be put in vertically, maximizing vertical space in your kitchen and cabinet. For the regular plate rack, it holds plates horizontally, occupying more face area, and it may not be as efficient in terms of space utilization. Spec number 2 is stability. For the stackable spring plate rack, the spring-loaded mechanism provides support and prevents plates from tipping or falling. And for the regular plate rack, it may not have the same level of stability as a stackable spring plate rack. It typically relies on the spacing and placement of dividers to prevent plates from sliding or falling. Next, for flexibility, a stackable spring plate rack is offer greater flexibility as you can easily adjust the height and number of plates you want to store. It can accommodate various plate size and adapt to your needs. For the regular plate rack, it comes in different size to fit different plates. They may not offer the same level of flexibility as stackable racks. The dividers may limit the number and size of plates you can store. Next, accessibility. You can easily remove or insert plates from the top without having to move other plates. For the stackable spring plate rack, a regular plate rack, it depends on its design. Some may require you to remove plates from the front, while others may allow access from the top. And lastly is price and availability. For the stackable spring plate rack, it depending on the brand and material. The stackable spring plate racks can vary in price. They may readily available in store or online retailing. For the regular plate rack, it is widely available and come in different price ranges depending on material, design and brand. Thank you.
Okay, for the conclusion, the stackable spring plate racks offers an efficient and practical solution for organizing and storing plates in the kitchen. Its design incorporates mechanical principles to optimize space utilization and plate security. The adjustable spring-loaded packs or dividers demonstrate the application of mechanical engineering in providing flexibility to accommodate plates of varying sizes. The rack's stackable features leverage mechanical stability, enabling plates to be stored vertically, minimizing the footprint required for storage. By implementing these mechanical elements, the rack enhances convenience and accessibility, making it easier to locate and retrieve plates when needed. Additionally, the durable construction materials employed in the rack to ensure its long-lasting performance, contributing to the overall reliability and functionality of the machine. Therefore, the stackable spring plate rack represent a successful integration of mechanical principle in a household machine, offering an organized and efficient solution for plate storage. As for the recommendation, based on the advantages, benefits, and prospective uses of stackable spring plate racks, we recommended the following actions. First of all, for determine space constraint, examine the available storage space in your kitchen, cabinets, or pantry if you have limited room or struggle with plate organization. Stackable spring plate rack can be an excellent answer. Determine plate size and amount. Consider the size and amount of plates you need to store. This information will assist you in determining the best size and arrangement of stackable spring plate racks to meet your specific requirements. Number 3, organize and test. Arrange your plates within the stackable spring plate rack, ensuring that they are securely held upright. Check the rack stability and accessibility to ensure they fit your expectation and demands. Number 4, share benefits and encourage usage. Inform the other members of the family or kitchen staff about the advantages of stackable spring plate racks, such as space optimization, plate protection, and simple access. Encourage them to use the racks on a regular basis in order to keep the kitchen organized and efficient. Number 5 and last, regular maintenance. Clean the stackable spring plate rack on a regular basis to promote cleanliness and prevent dust or debris accumulation. Inspect the racks for sign of wear or damage and replace or repair them as needed to keep them functional. By following these guidelines, you may successfully include stackable spring plate racks into your kitchen organization system, optimizing space utilization, plate storage, and accessibility.
Hello, my name is Mama Aris bin Ismail, CL210382. I'm from Group 4, and this is our project for mechanic of machines, which is the stackable spring plate rack. Okay, so our project has 3 main parts, which is the body, the base, and the spring. Okay, so next we would like to demonstrate the project. So we need to push it down first, and then push the bowl, the plate one by one, like this. Push. And then put it again until we put all the plates in. There. So the plate is okay. As we can see, the bowl and the plate is in the stationary because of the tension of the spring that put the plate and the bowl in place, so it doesn't move. From this project, the parts that shows the vibration application in this topic is the spring. So the potential energy comes before we put the plate and after we put the plate in the rack. As for the kinetic energy, comes while we put the plate in the rack.
Bersedia